All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, Mr. Q. All right, so warm-up number 73 is on your screen, and number 1 reads, rewrite each expression. Part A is 3 to the negative 4 power. Part B is 1/4 to the negative 3 power. Part C is 3 times square root of 3. Number 2, if x to the third times x to the fifth is the same as x to the 3 plus 5, because they're the same base, we're adding the exponents. We get x to the 8th, then rewrite 2 to the exponent of x minus 5. Number 3, it says rewrite 125 to the 2/3 power. And number 4, it says identify sine, cosine, and tangent of angle A, and they give us a right triangle. And the hypotenuse measures 13, and the legs measure 5 and 12. And angle A, B, and C, they give us C being the right angle, B is the larger angle, and part A is the smallest angle on the triangle. And number 5, it says copy the unit circle. And the unit circle is there so you can copy it. And once again, reminder, what's the last day for turning in any work in my class? Tomorrow. Yes? You're like, what? Right, Victor? Tomorrow? Victor? When's the last day?
Oh, Wednesday.
Wednesday, and if something goes wrong, Thursday, yeah. But last resource is what? Friday at 4 p.m., okay? So I'll give you some time to copy that and work on that warm-up. By now you should be able to do those on your own. Ready and go. All right, so by now you should be able to do all these by yourself. So let's move on. Our agenda for today, warm-up number 73. We're still on log functions, and tonight's home play is play sheet 16.1, numbers 1 through 12, all only. Copy that. Once again, warm-up number 73, logarithmic functions, and tonight's home play is play sheet 16.1, numbers 1 through 12, all only. Okay. All right, copy this in asynchronous code because the home play sheet, you're not going to find it on Canvas. You're going to find it on the asynchronous presentation. So make sure you copy the code. Ready? Here goes. Your asynchronous session code is NDLZP, NDLZP, NDLZP. All right. Once again, your home play for tonight is play sheet 16.1, numbers 1 through 12, all only. And you can find that in the asynchronous presentation. And it looks something like this. There's 16 of them. 12 of them, sorry. All right, let's get started. I can simplify logarithmic functions. So today, guys, we're moving on to simplifying logs. We've been graphing them, we've been transforming them, we've been solving and defining them. Today we're going to be simplifying using properties, okay? But we're also going to be looking at some definitions that we need to know, okay? So here we go. Where have we been? We already have our Freyer model. We have definition, example, non-example, and a hashtag, and we know that the logs are inverses of exponential functions. From there, we moved on to I wrote the definition as a question for a log, and from there we transformed logarithmic functions to exponential functions and vice versa. All right, that brings us to this. Copy these 3, please. Log base b to find the number of the same base b to the m exponent. Draw a line down. The next column is log base b to find the number of the same base b. Draw another line down, and then log of base b to find the number 1. All right, so these three guys, they're not properties, but these are definitions, which means they are basically things to look for in logs that should be obvious to us. Kind of like, you know, when we first started with variables and variable expressions, what is the one obvious thing about variables? That if the variable does not have an exponent, that means that there's an invisible exponent there, which is what? 1. That's an obvious thing. It's a definition. It's an obvious thing. It's not a property. It's just an obvious thing to look for. So here we go. These are the 3 most common definitions to look for. Look up. Here goes the definition for this first one. If you have a log with a base, look up. If you have a log with a base, that's the same as the base of the number given, and the number given has an exponent, then the answer is the exponent on the number given, y equals m. You're like, what? Yeah. So check this out. Let me show you with rewriting this. This is y equals log base b to find the number b to the m exponent. So what is my base here? Base is b. My exponent is y. And over here, we have the given number b to the m exponent. And what do you guys notice? That y is equal to m. But in short, in order to avoid doing all this, if we can actually see it, that the base is the same as the base of the given number, and the given number has an exponent, then that's our answer. All right, let's go to the next one. Whenever you have a log to a certain base, look up, and that base is the same as the base of the given number, then the answer is y equals 1. If you notice, this is very similar to this one, but this one doesn't have an exponent, so the exponent is 1. That's why it's y equals 1. So let me show you with simplification. We got y equals log b to find number b. So the base is b to the y exponent to find the number b. Now, they have the same base, and this one doesn't have an exponent, so obviously it's a what? A 1, so that's why y equals 1. Okay. Next. Last one. Whenever you have a log to doesn't matter what base, log to it doesn't matter what base, it could be 1 million as a base. But we're trying to find that the number is 1, the given number is 1, the answer will always be y equals 0. So let's look at that. Let's look at that through the simplification. Let's see. We got y equals log b to find 1. This is b to the y equals 1, but they need to have the same base, so b to the y equals b to the question. A base to what exponent is always 1? A base to what exponent is always 1? Yeah, 0. Any base to the 0 exponent is 0. All right, so now I gave you these just with variables. Let me give you some with numbers. Copy these down here, example Q. I got log 3 to find the number 3 to the 4th power. Then we got log 2 to find the number 2. And log 10 to find the number 1. All right, so let's use our definition, see if it works. Log base 3, does that have the same base as a given number? Yes. And the given number has an exponent, so my answer is what? Y equals 4. Next, log 2, does that have the same base as the given number? Yes. Does the given number have an exponent? No, so this is y equals 1. And this one, log 10 to find 1, so that means y equals 0. Anytime that the given number is 1, the answer is 0. All right, so those are the most common definitions. But let's get started with our first property of the day. Ready? Write this down. Our first property of the day is known as product property of logarithms. Product property of logarithms. And it's log b, and then the given number is m times n. M times n. All right, so this is called product property of logarithms because product means multiplication. Are we multiplying two numbers here? Yes, m and n. So think about these, since we have the base b, or it has the same base for both of them. So question, on the warm-up, when I gave you guys a variable of the same base that you multiply times another variable of the same base, what happens to the exponents? We add. So that means we can rewrite this as log b of m plus log b of n. Because we're thinking about bases and exponents, and we're thinking about product property. So log b of m plus log b of n, it's the same things. If we're talking about exponents, do they have the same base? Yes, we can write it with one base. There it is, log b. And what happens to m and n? We multiply them. So whenever you have an addition like this, if the logs are the same, we multiply the numbers. That's what the product property of logs says. All right, let's see it in action. Copy this. Example 1. Express each expression as a single logarithm and simplify if possible. We got log 2 to find the number 8 plus log 2 to find the number 16. All right, we're gonna do this one together since, like I said, I think these are fairly simple. You just need to see it in action so we can get the hold of the process. Here we go. So according to our property, I left it up here, if we have the same log and we have two different numbers, we write it as one log and we multiply the numbers given. Okay, so let's see, do we have the same log? Yes, same log, so we write log 2, and then we take the given numbers, 8 times 16. So let me simplify that. This is log base 2 and 16 times 8, 48, I got 4, 8 plus 4, that's 12. This is 128. All right, can I simplify this more? Yes, y equals log 2, 128. My base is 2. Exponent of y equals 128. Can I write 128 in base 2? Let's find out. 128 divided by base 2, that's 64. Divided by base 2, that's 32. Divided by base 2, that's 16. Divided by base 2, it's 8. Divided by base 2 is 4. Divided by base 2 is 2. So we got 3, 6, 7. So this is 2 to the 7th equals 2 to the y. So that means that y equals 7. Woo, let's go. Am I right? Am I right? Pretty good, right? Yes, Mr. Q. All right, so once again, if they give you two logs of the same base and they're adding them, you write it only as one log and you take the given numbers, multiply them, and then simplify to solve. All right, let's do another one. Ready? All right, here we go. Example 1Q. Log 3 to find 3 plus log 3 to find 81. All right. So here we go. Do we have the same log? Yes, log 3. And what do we do to the given numbers? 3 times 81. Let's simplify that. This is log 3 to 243. All right, so then we write it y equals log 3 to 43. Our base is 3. Exponent of y equals 243. So can we write 243 in base 3? 243 divided by base 3. 3 divides 24, that's 8. Divides 3, that's 1. Okay, so this one is divided by 3, that's 27. Divided by 3, that's 9. Divided by 3, that's 3. So that's 5, 3. So this is 3 to the 5th equals 3 to the y, which means y equals 5. Ooh, let's go. Let's go. Not bad, right? Now check this out. The process is the same as the one we just did. However, look up. If I wanted to do this a little bit faster, look at this one. What do you guys notice on this one? Same base. This one doesn't have an exponent, so that means this would be what? 1. Is that correct? Yes. And this one's base 3. If I was to write 81 in base 3, that's 3 to the 4th. That means that the answer is 4. So what is 1 plus 4? 5. Let's go. Let's go. Oh, let's do another one. Copy this one. See if you can do this one on your own. There it is. Log 6 to find number 12 plus log 6 to find number 18. Copy that and go. I'll give you some time for that. Ready, go. All right. Let's see. What'd you get for this one? Y equals to what? What do you think, Mia? What'd you get?
3.
Let's go. That is correct. All right, not bad. So, so far we covered the product property of logarithms. From 1 to 5, how comfortable do you feel with that? It's on your screen. 1 to 5. Yeah, 4, 5, 4, 5. Yeah, 4, 5, 4, 5, 4, 5, 4, 5, 4, 5, 1, 3, 4, 5, 5, 5, 5, 5, 5. Okay. Yeah, you're like, Mr. Q, this is a piece of cake. Choco flan. Choco flan, yes. All right. So think about it. We did product property of logs. That means that we took these numbers and multiply them if this was addition. Okay, so look, the next property is quotient property of logs. Write this down, quotient property of logs, which means log B, and they give us the numbers m divided by n. So if we had the product property and it became addition, what happens to this one, Addie, since it's now a quotient?
It gets divided?
Yeah, it's divided because it's a quotient. And the other one was a product, so they multiplied. But then on the other one, we added them, right? So what happens? Yeah, you subtract. So write this down. LB to find m minus log B to find n. So yeah, so whenever they give you two logs of the same base and they're subtracting, you take the numbers, divide them, and you just write it as one log. All right, let's see it in action. Ready? Example 2. Copy this, please. Once again, same instructions. Express each expression as a single logarithm. Simplify if possible. Log base 2 to find the number 8 minus log base 2 to find the number 32. And I left the quotient property over here on top just so you can see it and have it there. Let's do this one together since it's going to go pretty fast now that we got the process down. What do you guys notice? Do we have the same log? Yeah, so we write log base 2. What happens to the given numbers? Oh, we divide them. 8 divided by 32. Okay. Can we simplify this fraction here? Yeah, so this is log base 2 and this is 1/4. If we divide top and bottom by 8, it gives us 1/4. Okay, so let's continue. Y equals log 2 to the 1/4. Base is 2 exponent of y to find the number 1/4. What's another way of writing 4 and base 2? 2 to the second power equals 2 to the y exponent. They almost look the same, but now we have a fraction on this side. So how do we change it? Yeah, we send the 2 to the second to the numerator. So this becomes 2 to the -2 equals 2 to the y. And now that we have the same base, we can see that y equals to -2. Pretty good, yes? Yes, Mr. Q. All right. So, and notice it's the same process, guys. We just write the log. If they have the same base, we add it as 1. But now the number, since it's subtraction, we're going to divide the numbers. Simplify it, rewrite it, and then just find our solution. Let's do another one. See if you can do this next one by yourself. Example 2Q. And it's log base 4 to find 128 minus log base 4 to 100 to find log base 4 to find the number 8. All right, copy that and I'll give you some time to work on that. See how you do with that one. Ready, go. All right. So what'd you get for this one, Angie?
Y equals 2.
Y equals what?
2.
2. All right, let's double check. So this is log 4, 128 over 8. Log 4, 128 over 8 is log 4 to the 16, because 128 divided by 8 is 16, is y equals log 4, 16. This is 4 to the y equals 16. 16 can be written as 4 to the second, 4 to the y, and yes, y equals 2. Let's go. Let's go. All right, so now that we've seen both properties on your screen from 1 to 5, how comfortable do you feel? Yeah, 5, 5, 5, 5s, 5, 5, 5, 4s. Yeah, 5, 5, 5, 5, 5, 4s, 5, 4s. Yeah. So guys, basically, like I said, today's home play, the 12 problems that you're going to have on that play sheet from your synchronous code are all this, just the 2 properties that we covered, okay? So our objective was to simplify logs. Did we simplify logs? Yes. And just a reminder, guys, it says, Mr. Q says, if you're not moving forward, then you're already behind. Let's go. Let's go. All right, guys. So I'm going to let you guys go. Make sure you get to your asynchronous code right now, since you have a little bit of time left, and get started with that. And I'll see you guys next time. Peace. Bye.